as this is the next one. We did
Okay.
that. We did 15 last time.
Right.
Okay. So, where do we begin here? Let's begin a little bit by labeling that 1, labeling that as 1.
Okay.
That's what they give you as information. Now, it's the area of the inside. Let's call it the inside rectangle. What's this measurement from here to here? Hold on a second, Carol. Let me close my door. My dog creating a ruckus. So if the frame is 1 inch, what's the area, the length of the inside rectangle?
So that's 2 inches on either side.
All right. So what's this? This got to be X what?
I'm not sure I know what you're asking.
Okay, well this is X. What's the area from here to here?
It would be the area of the outside X minus the area of the inside X?
Let's talk about lengths instead. Don't jump straight to area.
I mean the length of that.
What is
X.
this length right here that I've labeled? The bottom one is X. So clearly the width of this inside rectangle is not X.
Right.
What is it? It's X minus something. How much smaller is it than this X?
It's 2 inches smaller.
Okay, so that's X minus 2.
Okay.
Now tell me the area of the white rectangle.
I don't know how I can tell you the area. Oh, so the bottom is equal to the inside?
No, the area of any rectangle is the width times the height, or the width times the length. So
right, but what I'm saying is each X is the same length.
Correct.
The bottom X is the same length as the side of the inside.
Right. Okay.
Okay, I hadn't seen that until now.
The key is dimensioning everything. Okay. From here to here, what is that dimension?
That would be X plus 2.
Okay. So now we have the width and the height of both rectangles. So what's the area of the outside rectangle?
So that would be X times X plus 2.
Okay, so now we have the two areas. So let's see, for what values of X is the area of the frame equal to the area of the picture? Well, what's the area of the frame equal to?
It would be subtracting the inside rectangle from the outside rectangle?
So it's the area of the outside minus the area of the inside. That's the area of the frame. Okay? So they want the area of the frame, which is the outside rectangle minus the inside rectangle. That's the area of the frame.
Mm-hmm.
They want it to be equal to the area of the picture, which is the inside rectangle. So it has to be equal to that.
Okay.
Now, let's plug everything we know in. the area of the outside rectangle is x times x plus 2. The area of the inside rectangle is x times x minus 2. Notice my use of parentheses.
Yes.
I want to make sure I don't make a mistake. And that needs to be equal. Let's see, that's the area of the frame. It needs to be equal to the area of the inside rectangle. So there is the equation that we have to solve.
So I see two numbers that are the same.
Well,
essentially the inside picture.
Before we get to solving that, let's make sure you understand exactly what we did. First of all, we had to dimension all of the unknown sides.
Right.
The little rectangle, we had to put an x minus 2 on it. And the big outside rectangle, we had to put an x plus 2 on it.
Right.
Okay, once we did that, then we can figure out the area of the inside rectangle and the area of the outside rectangle. The frame is the difference between the two. So this is the frame. And the difference between the two is that. So this whole thing right here is the area of the frame, and it needs to be equal to the area of the inside rectangle.
Right.
So let's go to solve this thing. What's the next thing we have to do?
Well, since it gives us numbers, don't we just plug them in?
No, it didn't give us any numbers. Well, we could.
In the answers.
Yeah, we could if you wanted. I'm not sure that'd necessarily be the easier way to do this. Let's do it algebraically because I see a whole bunch of stuff. This is gonna get relatively simple. Just combine everything. Start reading from left to right. What's x times x plus 2?
X squared plus 2x.
Keep going.
Minus x squared minus 2x.
All in parentheses. Equals
X squared minus 2x.
Okay. So now I see that, let's see, if I remove the parentheses, I'm running out of space to write here, I'll do it over here. The x squareds cancel, and I got 2x plus 2x, so I get 4x on the left equals x squared minus 2x.
How did you get the 4x?
Excuse me, that, oh, those two x's canceled. That should be 2x. Sorry.
Can you go back? I got lost.
Okay. Let's
where you have x squared plus 2x minus x squared minus 2x. And then you took the parentheses away.
Yeah, which gave me x squared minus 2x, excuse me, x squared minus 2x, that was that.
That should be x squared plus 2x.
You're correct. My mistake. Thank you. Minus x squared plus another 2x.
That's x squared minus 2x.
Oh, let me start.
Oh, but then you add them, right? Okay. Now I get the.
Now I'm getting confused.
When you subtract the 2x, it becomes, since it's a negative 2x, it becomes a positive.
Yes.
I'm confused.
Why? Okay. So that's x squared minus 2x. That's the left side of the equation. That's the right side of the equation.
Right.
Now let's remove the parentheses. X squared plus 2x minus x squared plus 2x equals x squared minus 2x.
Okay, so that's where you got the 4x.
Now that cancels. And over here on the upper right, I'm going to write it. 4x is what's left on the left only. And it's equal to x squared minus 2x.
Correct.
So now we have 0 equals x squared minus 6x.
Okay.
Now let's solve that. How do you solve that?
Well, you take an x out.
Okay, so I got 0 equals, you factor an x out, giving me
X times
2
6.
solutions. Solving this equation, what are my 2 solutions? 0 is one of them.
-6,
No.
+6. So how, just out of curiosity, how do you get the 2 x's so that 1 equals 0 and 1 equals 6?
Anytime you have 2 things multiplied together that equal 0, well then both of them can be 0. One of them has to be 0. Well, that can be 0 or that can be 0. And if you set each to 0, you get that solution and you get that solution.
Okay.
However, in the context of this problem, x equals 0 doesn't make any sense. So that we call an extraneous solution. And the only x that works is 6.
Okay.
Now, that was a heck of a lot of work.
So I'm just trying to conceptualize the question. How can a frame equal the inside of the picture?
Well, what they're saying is the area of the frame.
Oh, okay. It's the same as, okay.
Equals the area of this.
Okay. I understand now.
Okay. Now, that took me probably 2 minutes to do.
Well, because you were explaining it to me.
Possibly. But there were still a lot of steps to do on that. I'm wondering if your suggestion wouldn't make more sense. Let's start with 5. Always start with we're going to back solve this instead of algebraically solve it.
Okay.
Okay. And you'll usually start with the second lowest. And does 5 work? Well, if that is 5, excuse me, you know what? This is not going to lend itself to back solving. It just occurred to me. It's going to be hard to back solve this because the answer is the area of the frame equals the rectangle. The answer isn't, yes it is. Yeah, we can back solve this. Sure. If x is 5, then we know this has to be 3, right?
Oh, because of 5 minus 2, right?
Right. And if this is 5, this has to be 7.
Mm-hmm.
So the area of the frame would be 35 minus 15. And the area of the picture is 15. So they're not the same.
They're not the same.
The frame is bigger. So that means we need to go up with our value of x. Right? In other words, that immediately tells us we don't need to consider that one. That's why we start with the second lowest. We don't need to consider that one. What we do want is to consider a higher one. Now, there's an E under here that you can't see. The next one we're going to do is that one right there.
Why wouldn't we do 6?
Well, because 6 won't tell us what the answer is. If 6 tells you got to go higher, then you got to
Oh, okay.
Whereas,
so what is E?
Don't care, don't matter.
Oh, okay. You can't see it either.
I
Okay.
can't see it either. Here's why you don't need to know. So if we assume that 7 is correct, then that's 7. This is 5. This is 5. Excuse me. This is 7. And this is 9. Now, the area of the frame is 63. The area of the picture is 35. The difference is 27. Something's wrong. 7 times 9.
8. 28.
28. So we got the area of the frame was too big, meaning we need a bigger X. Yet, hold on a second. Let's go back and try 6 just to see.
The bottom number is 8.
Algebraically, let's make sure 6 works.
The bottom number is 8.
Okay. We're going to test 6.
Okay.
Let's make sure that our algebra was correct. We came up with an answer of 6. And normally I wouldn't test it. But if I'm back solving, then I'm just going to go through these. Well,
sure.
The area of the frame is 48. Excuse me, the area of the outside. The area of the inside is 24. Therefore, the area of the 24 is equal to 24. Same as the inside of the picture.
It worked.
So our answer worked. Now, I did something wrong. Let me just go back and correct it. Because 6 was not the next one to try. 7 was. And here's what we get when we do 7. That's 7. That's 5. That's 7. That's 9.
Okay.
The area of the rectangle is 63.
Mm-hmm.
The area of the inside is 35. Therefore, the area of the frame is 28.
Mm-hmm.
And the area of the picture was 35. So the area of the picture is bigger than the area of the frame, meaning we need a smaller x.
There you go. Okay, so that makes sense. I did
5, it told us we needed a bigger x. I didn't do 6, I did 7, because 7 is going to tell us the answer. Either 7 is the answer, or it's going to tell us we need to go higher or lower. If we need to go higher, we'll know that E is the answer without doing it. If we need to go lower, we'll know that C is the answer without doing it.
Got it.
So this technique of when you are going to solve, and in actuality, back solving may have been the fastest way to solve that. But when you're given 5 choices, you do not start with the middle one. Probability dictates that if you start with either the second lowest or the second highest, then the most you'll have to try are 2 answers. By starting there, first of all, that works. I'm done. If it tells me I got to go lower, I'm done. If it tells me I got to go higher, then I go to the second highest. And this will tell me whether it's either going to be right or it's going to tell me I got to go higher or lower. In other words, I'm done once I try D. With this technique, you'll never have to try more than 2 of the 5 answers, as long as it's a problem where you're going to be able to tell whether you need to go higher or lower.
Right.
You can't always. Some problems look like they lend themselves to back solving, but when you do it, it's kind of reverse, and you don't really know whether you need to go higher or lower. But notice in this problem here, if I get the area of the frame being, if the area of the frame is greater than the area of the picture, Well, then clearly I got to make the area of the picture bigger, which means X has to go up.
Right.
If the area of the frame is less than the area of the picture, when I try my back solving, then X has to decrease. And I'm not sure that's 100% obvious. Even when I'm looking at it in hindsight, I'm not sure I would know that for sure. And the only downside of that is you may have to try all 5 answers.
Right.
In other words, worst case scenario here is you'd start with A and then try B and then try C, and C will give you the answer. But as long as you know which direction it has to go, then this technique where you start with either the second lowest or the second highest, doesn't matter, either one. As long as you know which direction you're going to have to go if that one is not correct. Boy, I do enjoy these GRE tests, I have to tell you. Just because they're very challenging. They're not so challenging that I can't do them, but they're very challenging. Each one of them has like 5 steps.
Yeah.
That problem did. It had 5 steps. You had to figure out the dimensions, then you had to figure out the areas of each, and then you had to figure out the area of the frame. Then you had to solve the equation, which was a quadratic. You had to factor and throw away one of your solutions. So there were 5 definite steps in that. All right, percentage of 300 people in group 1 and 400 people in group 2 who have selected ailments. Okay. Hate to... let's look at that whole table before we... And let's look at problem 17. The number of people in group 2 who have hay fever is how much greater than the number of people in group 1 who have hay fever? It's the first step.
Finding the place of hay fever for both of them.
The number of people.
4% for group 1 and 10% for group 2.
So convert those to numbers of people, because that's what they're asking about. They're not asking
300 people, so we need to know 4% of 300.
So that's equal to 12. About group 2.
You just knew that off the top of your head?
4 times 3 is 12, yeah.
Oh, okay. So 10% of 300 would be 30, right?
It's 400 with group 2. That's why I didn't want to take that off the screen.
Oh, 400 people, yeah, 40.
So that's 40, yeah. Coming up with this off the top of my head, I knew that 1% was 3. So 4% has to be 4 times 3. That's really the way I did it. Because it wasn't, just 4 times 3. I had to figure out the number. It could have been 1.2, it could have been 12, could have been 120. So I start really with figuring out that 1% of 300 is an easy problem. 10% is 30, 1%'s got to be 3. And now it's just 4 times 1, or 4 times 3, rather.
Right, okay.
Excuse me.
Bless you.
Sorry, I usually sneeze in 3s. Other one's not going to come though. Okay, so the question is, the number of people in group 2 is how much greater than the number of people in group 1? Speaking of hay fever. It's the answer. Without looking at the multiple choices even.
It would be 28.
Yep. D. All right, now this is going to be tough. Let me look at the question. Oh my goodness, there's... Let's see. For the 7 ailments, what's the median of the numbers of people in group 2 who have the ailments? Okay. Well, what do we have to do?
Do we have to put them in order from least
First
to
of all,
most?
we have to put the number of people in each group that have these ailments. Right now, all we have is the percentages. In other words, both these first 2 questions, we have to convert that percentage to a number of people. And then put them in order, then find the middle number.
Well, 5% on the bottom is going to be 20 because that's half of 10%.
Huh? Use your calculator here.
Okay. $84 for the top.
Should be 82. Nope, 84, you're right. Now, before we go further, I want to make sure I don't forget to ask you this question, because I discovered it on my calculator. I have a calculator very similar to the one you're going to use on your test. Okay?
All right.
I want you to do -6 minus 10 on your calculator right now, just to make sure you know how to do that on that calculator, because it's not obvious. What's it tell you?
It tells me 4.
Ah, that's because, I'm glad I mentioned this. You can't use the minus sign in front of the first number. You have to use the other minus sign. Do you have a button on your calculator that has either a plus minus or a different minus sign? Hit that, then hit 6, and then hit the subtraction sign and hit 10.
-16.
Which is correct. So if you have -5 minus 7, that is the subtraction sign on your calculator. That is not. That is a different key entirely. That is either the negative key or the plus minus key. On my calculator, it shows as plus minus. It looks like
same here.
Okay.
Same here.
Well, that's why you had problems with that problem the other day, is when we had -6. Remember when we had the exponents? And you were trying
right.
-16? It's because the calculator kept giving you -4.
Right.
So do not make that mistake on that calculator.
Okay.
The easy one to make. In fact, it's one of the main reasons why so many of my students have problems with this problem, because their calculator doesn't even give it to them right unless they put it in a very specific way. When you have a more advanced calculator, there's actually a key on it that says a negative sign in parentheses, and that's what you hit in front of the 6. But on these little calculators that you're going to have to use for this test, you got to make sure that when you want a negative sign, you put it, not the subtraction sign.
Okay.
Okay. So let's continue on. I didn't mean to interrupt this problem, but I wanted to make sure I didn't forget to cover that, because that'd be a horrible mistake to make.
Right. So the second one down is 16. Third one down is 12. Then we have 40. Then 44. Then 24.
Okay.
And then that's everything.
Now let's line them up in order.
Are we going to line them up smallest to largest or largest to smallest?
Usually smallest to largest, as all we're looking for is the middle number, and we just found it. I don't really have to go any further. The 4th number is the middle number. But just to be safe, We had a 40, we had a 44, and we had an 84. Now the median is always the middle. If there are an even number of numbers, then the median is halfway between the two middle. Okay?
Right.
All right. Let me scroll down and see if I can figure out the third question that applies to this table. The number of people in group 1 who have wheezing is what percentage greater than the number of people in group 1 who have non-allergenic wheezing? Okay. So we got two types of wheezing. We got these two right there. Let's put some numbers on these. What's the number of people in group 1 that have allergic wheezing?
9.
5 times 3.
In group 1?
Huh? It's 300 people in group 1, and 5% of them have allergic wheezing.
That's a 3.
3 times 5.
Oh, we're down there. We're down there. I was looking at asthma. Okay, sorry.
That's all right. And then the number of people that have non-allergic wheezing is how many?
Okay, so 15 for the wheezing, and the non-allergic would be 6.
Okay. So we got 15 to 6. Let me just look at the problem again.
What percent greater?
Okay, so we're gonna go 15 compared to 6. 15 to 6. What is that? First of all, if it was 12 to 6, what percent greater would it be?
Twice. Oh, percent would be 200, right?
It would be 100% greater. It's a little.
Oh, because it's one.
It's a little tricky. Yeah. If I had 12 to 6, that would be 100% greater. If I had 6 to 6, that would be 0% greater. In other words, it's not greater.
Right.
So you take the two numbers, you divide them, and then you subtract basically 1. So when I divide 15 by 6, I get 2.5. And thankfully, they did not put 250% on there as an answer. So we know there's something wrong with this answer if this is what we did. Well, it's not 250% greater. It's 9 greater. 9 divided by 6 is 150%.
Wait, where are you getting the 9?
15 minus...
Oh, you subtracted.
Yeah, so there's 9 more people divided by 6. So it's 150% greater.
So, okay, I'm sorry.
This is not an easy concept to understand.
15 minus 6 equals 9, right?
Right, and then we're going to take 9 divided by 6 to come up with our answer.
And that comes up with, hold on. 9 divided by 6 is 1.5.
Mm-hmm.
And that's how you get 150.
Right.
Wow, that's tricky.
It is a little tricky. And the way to really figure it out is with these other two examples over here. In other words, if they were both 6, and I said, how much greater is one than the other, you would say none. And yet 6 divided by 6 comes out to be 1. So how come it's not 100% greater? It just isn't. It's got to be greater. It's not, they're not asking you, what is this number as a percent of that number? Then the answer would be 100. What they're asking is how much is the numerator greater than the denominator?
And it's not greater at all.
Greater at all. So that has to be 0. So how do you get 0? You basically subtract 100 from any percent you get, or you subtract 1 from any number you get. If I had two numbers that were, group 1 had 12 in it, group 2 had 6 in it, I would say group 1 had 100% more than group 2. I would also say that group 1 has 200% of group 2. So the real key question here is, are they asking more or of? If they were saying, what percent is group 1 of group 2, then this answer for our question would be 250%. But when they say, what percent is group 1 more than group 2, that is a different question. Then you have to take the difference of the two and divide by group, the bottom one.
Aha.
So it all comes down to more or of. And let's hope that's the last question. Good. Just because it's hard to do the way we're doing it here. I can't see both the table and the questions.
I know.
Shoot, we got another one here. Let's see, what's the ratio of the number of people in group 2 with the ailment sneezing and itchy eyes to the number of people in both groups with the ailment sneezing and itchy eyes? All right, group 2, what's the ratio? Group 2 to both groups. That's what we're doing. Group 2 to both groups. And the two ailments are sneezing and itchy eyes.
So we're looking at the number of people, right? So sneezing and itching eyes in group 2 is what we need?
We need sneezing, yeah, that's just one category. Okay.
So there are 44.
Okay. What is in group 1?
And group 1, I didn't do that one. That one is
8 times 3.
24.
Okay. Now, what their question said, we got 44 in group 2, 24 in group 1, and they wanted us to compare group 2 to the total. So group 2 was 44. What was the total?
Of the total of what? The total of group 2?
The total number of people in both groups that have sneezing and itchy eyes.
So that would be 68.
There's your ratio. Now, I wonder if that would count. Or do the instructions tell you you have to reduce it to the simplest fraction?
Enter your answer in the boxes. It does not say.
Okay. I would assume you have to simplify. So simplify this for me. You still want it as a ratio, but it's not simplified. And the only reason I know for sure is because I have an even number in the numerator and an even number in the denominator. So I know for sure I can divide both of them in half. So let's start there.
11 over 34.
I can divide them in half again. Hold on. You only have to divide them in half, and then if you do it again, you got to make sure you divide both of them in half again. So there's
11 over 17.
Now, I know you'd get credit for that one. Whether you'd get credit for that or that, I'm not sure. There's no reason to leave it in these unsimplified. So I would never put that as an answer. I would always simplify it and give it that. Whether or not you lose credit or not, I do not know. I'd have to go back and read the directions as to are they going to insist that you give all fractions in simplified form. And I don't mean in decimal form. Obviously, they want a ratio.
Right.
They want a fraction. So you don't want to stick that 44 over 68 into your calculator and come up with a decimal. That doesn't work for sure.
No.
So you have to take the fraction and reduce it or simplify it. All right. Finally, not that table anymore. Not that those were hard. Those are actually 4 very easy questions.
Yeah.
I expect you to get all 4 of them right. It's just a question of going through the procedure properly and using your calculator and putting numbers instead of percents in all of those boxes.
Right.
Okay.
So since I can't write on the test, and I'm taking notes as we're going along, and I was writing all the numbers down in the chart as we were talking about them. When I'm taking the test,
I see the problem.
Should I write all the numbers in the chart on my scrap paper?
Yeah, I would do it this way. That's group 1, that's group 2. You got 7 categories. You're going to have to at least do this on your private piece of paper. 1, 2, 3, 4, 5, 6, 7, and then put your numbers in. I don't remember what they were, but that was 40. Fill in all the numbers. Once you have this on your piece of scratch paper and you have it all in numbers instead of percentages, now you actually can refer to this and answer all 4 questions.
Right. Okay.
So yeah,
I was just making sure.
Yeah, since you can't write on your test, yeah, I don't know any other way to do it. And you want to put it in a form where you can see it readily. I'm not sure you necessarily need to label it. I don't think you need to go to label each of those.
No.
You need to know row 1, 2, 3, 4, 5, 6, 7, maybe.
Right.
You don't want to get off a row. That would be catastrophic.
Right.
But don't spend any more energy or writing than is absolutely necessary.
Excuse me, right.
Okay. Yeah, it would definitely be a waste of time to write all of those things. It's probably why they did it the way they did it. You notice that every one of those ailments is, my God, it would take me 20 seconds to write each one out. So they don't really want you to do that. And the people that do are going to get penalized for it. All right, let's see. Whenever I see a question like this at the end of a question, and it's one of these answers, my mind goes to back solving.
Okay.
Okay. Let's just try it. And then we can go back and we can look at the algebraic way to figure it out. But I most of the time back solving is the better way. Where are we going to start?
So you said usually start at the second lowest?
Yeah, that's where I always start. Unless the question says, what is the minimum number of people in the survey? And then I always start at the lowest number.
Okay.
Or if it says, what's the maximum number of people in the survey? I start in the biggest number. But if it doesn't, it just says, what's the total number of people in the survey? And I don't know, I don't have a clue as to which one. I'm going to start at the second lowest. And the reason I do the second lowest rather than the second highest is because the math's a little easier. The math's going to be easier with 2100 than it is with 2700.
Okay.
We have to figure out all these numbers. So
252 people would be between 40 and 60 years old, is that?
Yeah, let's not get to that far yet. Let's take this and put a number on that. We're saying there's 2,100 people in the survey. What we're going to try to do is prove that that's correct.
Oh, I see. Okay.
So what's 58% of 2,100?
Okay, hold on. 1,218?
So
that doesn't sound right.
That's 58% of 2,100. That does sound right.
Okay.
More than half. What'd you say, 12,100?
1,218.
Excuse me, 1,200. I just wrote the 8 wrong, that's all. 1,218. Hold on, I'll get there. That doesn't sound right. Give me 58% of 2,100. 1,218. Okay, that does sound right. So 1,218 are aged 0 to 40, correct?
Yes.
Okay. 70% were aged 0 to 60. So what is that?
1,470.
1,470 were aged 0 to 60. If 252 of the people were more than 40 and at most 60, what were the total number of people? Well, how are we going to get that? That's not 147, that's 1,470, okay. So how many people, based on these two numbers, and assuming 2,100 is correct, how many people are from 40 to 60?
How many people are from 40 to 60? Does that mean all of them?
No, we got 1,218 people that are 0 to 40, and we got 1,470 people that are 0 to 60. So how many people are from 40 to 60? So
we subtract.
Correct.
Oh, okay, I added. Okay. 1,470 minus 1,218. 252.
So our first guess was correct.
Woohoo!
Now the question is, let's just go back. That's easily the easiest way to solve this particular problem. But let's not pick the perfect number and see if this is going to tell us whether we need a bigger or a smaller number. So let's start with 2,700, which is equally valid to start with. Now tell me how many people are 0 to 40.
Hold on.
Take 58% of 2,700.
1,566.
And from 0 to 60.
2,700.
Times 70%.
1,890.
Okay, so that does not give us 252. That gives us 324. So does that tell us we need a smaller number or a larger number?
Smaller.
Definitely. In other words, we need to bring both of these numbers down so that their difference will be a smaller number. We're trying to get to 252.
Right.
So definitely on this problem, that whenever you can tell which direction you have to go, then back solving is going to be easier virtually 100% of the time. It just is. Even if you can't tell the direction, it's usually going to be easier. I mean, the worst case scenario is you have to try 4 numbers, right? You try all 4 numbers and they don't work, then the 5th number is the answer. So the worst case scenario is you have to try 4 numbers.
Right.
And I tried 2,700. I need a smaller one. Notice why I do not try 2,400 next. Because it's going to give me an answer, and it's all I'm going to know is I need a smaller number. I still don't know whether it's A or B.
Right.
So if I were to try D first and then C, I still got to try B. I got to do three sets of math. So that's why you don't try C next.
Right.
You try B, and then that tells you what your answer is. Either you need a smaller number, you know what it is, you need a bigger number, you know what it is, or it's perfect itself, as it is in this case. I actually saw SAT books that recommended you always start with letter C. And that is absolutely wrong. Based strictly on probabilities, the number of trials that you have to make, if you start with the letter B, 40% of the time you get it right immediately. Because whenever A or B are the correct answer, you're going to get it on that first attempt.
Right.
Whereas when you start with the letter C, you're only going to get it correct 20% of the time. And then you'll have to do another one.
Right.
So B actually gives you a 40% chance of getting it correct on the first trial, B or D. So it's much better to start with B or D than it is C. As long as it's not saying minimum or maximum, then you have to use those keywords in your solution. I mean, in your where to start your back solving.
Right.
Which of the following is equal to 1.25% of X?
1.25% of X. So since X is in all of the answers, we have to plug in numbers.
No, not really. Here's what you have to do. You have to separate that out. That is equal to 1/80th times X. This is equal to 1/8 times X. This is equal to 1/4 times X. So
can you explain why you're doing that?
Yeah, because you want to know what percent that number is. That's
okay.
That's 0.25. That's 25%. So answer C would be 25% of X.
Oh, I see. Okay.
Answer E would be 75% of X because that's equal to 3/4 times X. Pi, get up here. Pi, come here. Pi, come here. Come lay down. Stop barking. 2 dogs in the house. One never barks hardly, but howls whenever it's happy or whatever. And then the smaller one that just likes to yap all the time. So what's our answer here?
1/8.
That's 1/8 is 12.5%. Not a bad one to memorize. 1/2 is 50%. Let's just call it 0.5. 1/4 is 0.25. 1/8, just keep dividing that number in 2. You get this. Well, that's not what they're asking. That number is 12.5%. So what's the answer?
Would it be 5/8?
No, that's 62.5%. Do it in your calculator. You got to come up with an answer that's 0.0125.
So that's 1 divided by 80.
Okay, that's the answer.
Oh, because you have to multiply by 100 then. Okay.
Correct.
Got it.
Okay, in other words, the problem here is really how to convert this. It's twofold. You have to know that X over 80 is the same as 1/80th times X. And that's what this means. When it says it's equal to percent of means multiplication in word problems. So it's equal to 1.25% times X. And that is the only answer that is 1.25% times x.
Okay.
Okay. Well, the next one I can tell is going to be hard just by looking at it. Nah, maybe not. For some reason, these, when I see answers like this, I think it's more difficult. But that's just first impression. May not actually be. May actually be fairly easy. Alice earns $D and has T% of what she earns deducted for taxes.
I'm not sure why I have those 1 marks in between there. Those, I'm sorry about those. Those should not be there.
No problem. She earns D and has T% of what she earns deducted for taxes. So what does she earn?
She earns D and has T% deducted.
Yeah, in other words, we're not trying to answer the question. We're just trying to answer this part right here. Well, let's say she earned $100.
Okay.
She had 10% deducted for taxes. So how much does she have deducted for taxes?
That would be the 10T.
No, I'm just saying that if this was the case.
Oh, she would have $10. Okay.
She would be left with $90. Now, how do you get 90 as an answer? Well, you start with what you earn, and you subtract your percentage rate times what you earn. So that's how you get 90.
Okay.
With this being T. So we've got D is what we earn minus 0.1, excuse me, minus T. Sorry, hold on. Minus T times D. So that's her take home. Take home pay is D minus T times D.
Okay.
Okay. How much of what she earns does she have left after taxes? Okay, well, this is easy. How am I going to do that? How am I going to match it up with one of those answers? This is the answer right here, but that's not on the test. When you're looking at something like this, automatically you should be thinking something. What are you going to do that?
D out.
Factor.
Taking.
Factor, factor, yeah. Factor, factor, factor. Think those words. They're very frequently the right thing to do. When you have an expression that can be factored, you almost always need to factor. I say almost. So factor that.
That would be D in parentheses 1 minus T, which is C.
Correct. Now,
so I'm sorry, what did you say means that you always factor?
When you see an expression that can be factored.
Okay.
When I look at that expression, I don't see D minus T times D. I see something I can factor a D out. Now, that's because I spend, 4 hours a day doing algebra with people. So I'm always looking to factor. But you should be too. In other words, okay. It's easy enough to come up with this answer over here, but that answer isn't on there. So you got to turn this answer into one that's on there and think factor. Once you factor it, you do get something that's on there.
Okay.
Okay. Yeah, now notice that I did pick some numbers here. And this actually is one of those problems where, remember what I said, that if you see a problem that has variables in the problem, and variables in the answers, each answer has a D and a T in it. That means that D and T are not specified, and you can make up whatever numbers you want for it. So pick some nice simple numbers like I did, like $100 for her earnings and 10% for taxes. And once you do that, then it's relatively easy to come up with what the formula should be.
Right.
But without picking the numbers, it's a little harder. Another way to do this, if I were really to follow through on my strategy, usually when you pick numbers, you then back solve. Okay?
Right.
So if I pick these two numbers for D and T, I know that her income is $90, right?
Mm-hmm.
So if I go through each answer and determine which one is $90, I don't need to do any algebra. What's the first one? If D is 100 and T is 10%, what is her answer? What is A equal to?
D would D is 100, so 100 times 1 minus 100.
No.
Wait. Minus 1,000.
Well, 10% has to be always converted to a decimal. 10%.
Oh, okay.
0.1.
0.1.
Okay, so 0.1 times 100 is 10. 1 minus 10, that doesn't work. That gives you a negative number. How about this one? This one, we have 100 times 1 minus 1. That's a 0. That doesn't work. This one, we have 100 times 1 minus 0.1, which is 10%. So that's 100 times 0.9. That gives us 90. That's what we know our answer should be. That's the answer. I didn't have to do factoring. I didn't have to do any of that. In other words, I solved this entire problem by picking numbers, simple numbers for D and T, knowing what the answer, as long as I pick simple numbers, then I'm going to know how to get her take-home pay pretty easy.
Right.
So with these two numbers, I know she takes home $90. So use those two numbers until you find $90 as an answer.
Right.
That's called the third technique, which I like to call picking numbers and then back solving. There's three techniques. There's algebraic solution, there's back solving only, and then there's picking numbers, and that's almost always combined with back solving. Picking numbers and then back solving. So those are the three techniques normally that you have. I'm sorry, I've taken you over. I will, what is today? Friday? Sunday? Sunday. I'll talk to you Friday.
Okay, thank you.
All right, Carolyn. Bye-bye.
Bye.